Here we have a problem. We have two vectors a and b. So now if the magnitude of a and b is given, say if my vector a, the magnitude of the vector a is say 2, then if I ask you to find out what is the magnitude of the vector b, can you find out what is the magnitude of the vector b, or how can you find out? So look, here we have x-axis and y-axis, and we have small unit squares here. Since our graph is small unit square graph, so we can try to find out the value of unit square. So otherwise we can't find the value for b or magnitude of b. So what can I do? As we know, we can resolve any vector into components. So the vector a has two components along y and along x. So it is a sub x, this is a sub y, but we don't know what is the value of ax and what is the value of ay, but we know that the magnitude of the vector a is square root of ax squared plus ay squared. So let's consider one small square is x. I'm calling it, okay, we have already used x so many times. For x is for the subscript, so we can say one small square equals cd squared. That means the side of each square, the sides of the squares will be d. So now here you see 1, 2, 3d. So ax can be written as 3d. So I can write ax is 3d. So I need to square it, plus ay is 1 and 2. So I have 2d here. 2d, also need to square it. So what will we get? Our result will be 9d squared plus 4d squared is 13d squared, and which is square root of 13 times d. Okay, so now we know the magnitude of a, which is given, which is 2. So this will be equal to 2. So we can find it from here, the d equal to 2 over square root of 13. So if I press my calculator, 2 over square root of 13, it is 0.6. So let's call it 0.6. I'll consider up to 1 decimal point. So if it is 0.6, so the value of d is 0.6. So I know now what is the magnitude of b. The magnitude of b will be root over bx squared plus by squared. So what is bx and what is by? Say along bx, this is bx. So how many squares are there in bx? 1, 2, 3 squares. So it is 3 square means 3d. 1 small square equal to d. So bx should be replaced with 3d and it is squared plus by the vertical component will need to 1 2 3 4. So 1 2 3 4 5. So total I have 5 square here. So it will be by will be let's change the color. By will be 5d whole square. So it will be 25 plus 9. It is 34, so it will be root over 34, right? D. So the magnitude of B is, okay, still we need to go a little bit further, which is square root over 34 times D is, we have calculated it here, so put it here 0.6, and let's make a little bit space here. So it will be 0.6 square root of 34, which is 3.5. So I'm getting it 3.5. So what is the magnitude of D? It is 3.5. So it is 3.5. Magnitude of B is 3.5. So now I know the magnitude of A and B. So I'd like to erase a little bit of space here. So now I need to add this to vector. So where is it is my B. So B and A, we need to add these things. It is very easy. We need to complete a parallelogram, and or we need to drag the vector A, and we need to put the vector here on top of the vector B. So we need to make 1 2 3 1 2 3, okay, the same as this, and the direction should be the same. So here it is, I think. And now here's our vector, a little bit shorter. It's all about the drawing, so let's consider it like this. So now if I'd like to add these two vectors, what I need to do, I need to add the tail of the vector to the head of the vector. So if I take the tail of the vector here, if I put here tail, and I need to go up to here at this point. A little bit short because I have drawn my vector A. So what I did, I just dragged the vector here A to this point, and now I am adding the tail and the head of the last vector. Okay, so the red vector is our resultant vector. So what is the magnitude of the resultant vector, or red vector, or not red vectors, let's call it, since we can give name to vector, it is C. So what is the value for C? So we don't need to find out anything else, because we have already get our value, which is what? Say we know the small square is, we have already found it, 0.6. So we can see the C vector, the vector C, which is very straightforward vector. So we have no x component of this vector, only the vector is along the y-axis. It is parallel to the y-axis. That is why we don't have the x component. So how many squares are there along? So 1 2 3 4 5 6 7. It should be 7d. Okay, so the magnitude of the vector, the magnitude of vector C will be just 7 times 7 unit along the y-axis, so it is 7d, and we know the d is 0.6, which is 4.2 perhaps. Okay, check the calculation. Now the other question is, let me finish this shortly. The other question is, what if we need to add, say, what if we need to calculate this thing like a minus 2b? So where is the 2b? So always we know that a minus can be replaced as plus 2 times negative b. So I need the negative vector of b and I need to multiply it 2 times. So I can draw this vector negative of 2b. Okay, let's let's revert the problem. It will be hard for me to draw because I don't have enough space to draw 2b. So let's do it like what if I would like to calculate b minus 2a? So I need to draw the vector a. So I can draw the vector a. So I need negative 2a. So it is a up to this point. So we need to go a little bit further. So 2 times this. So it is negative 2a. So if I have negative 2a, then I am almost done, because here I have negative 2a, because you see up to 3 unit, okay, 1 2 3 unit, the vector is here is a, and another 3 unit we have the vector another a, so it is 2a, since the direction of the vector a is opposite of this vector, original vector. So now, so what is b minus 2a? That means I need to add b with 2 times a, so negative 2 times a. So it is negative 2 times a. I need to add this thing with b. So what I need to do, I need to drag this vector to the tip of a, or I need to drag a on tip of this. So let's bring the a vector here. It will be easier perhaps. Here our a vector should be drawn here. It is 1 2 3. It's like this. Maybe I have drawn it a little bit tilted. So now the resultant vector can be drawn from here, from origin to this point. Okay, this is the resultant vector. We have got this. So this red one is, this final red one is b minus 2a, and you know here is a and the whole thing is 2a. We know how can draw 2a. So yeah, so we could also draw 2b, but here the space is a little short. If we draw this, then it will be hard for us to draw the resultant vector. Okay, thank you.